Hello everyone, my name is Suram and I welcome you all to my YouTube channel. Today we are continuing with the same chapter, that is the refraction of light, and today we are going to discuss the important topic in this, that is the real and apparent depth. Real and apparent depth. What is this real and apparent depth? You people might have noticed that sometimes if the coin is placed inside the tub that is containing water, then coin seems to be raised from its lower surface. Okay? So why it happens? That happens because of the refraction of light. This is happening because of refraction of light, right? The refraction of light is the phenomena that is responsible for this, because light is traveling from air to water. Okay? So light is traveling from air to denser medium, so its speed will get decreased. That is the reason of refraction. Okay? So because of this, that the coin's lower surface seems to be raised. Is it? So we will discuss here. Let this is the surface of water here. We will consider that this is the inside of the water. This is the water surface, and here is the air. Two mediums are there, water and air. So any object is placed, suppose here, any O is the object here, is it? As given here also you can see O is the object here, right? And if you view it from here, from the top, means at an angle 90, then you will see the ray of light will pass straight. Is it? At 90 degree, the ray of light is falling at 90, then it means it will pass straight and it will return back along the same path. And if we are viewing it from a certain angle, from this side, suppose, is it? Then the ray of light will go like this, is it? And here again this will be the normal line. Is it? This will be the normal line here, and a ray of light will get refracted away from the normal, because it is traveling from denser to rare medium. Is it? So this angle will be the angle I, is it? And this angle will be the angle R. Is it? So this ray seems to be coming from actually this point. Is it? That this point is I. Is it? This point is A and this point is B. Is it? Okay. And if this angle is I, then this angle will also be I. Is it? Because these are this line and this line. These two are the parallel lines. Is it? This is also normal and this one is also normal. These are the two parallel lines. And this is the transversal line. So this angle is I, this will also be I, because these are the alternate angles. Is it? And in same way, if these are the two parallel lines and this is the transversal line, if this angle is R, this will also be R. Is it? Because these are corresponding angles. Is it? These are the corresponding angles. So here you can see, if we see this triangle AIB, so let it be AOB first. In triangle AOB triangle, what is there? If we have to calculate the sine I, value of sine I, what will be that? This is the triangle, this angle is 90 and this is I, so it means this will be P over H. Sine I, we are knowing that it is perpendicular over hypotenuse, P over H. So P is here, that is AB, and H here is here, that is OB. AB over OB. Is it? And in same way, in triangle AIB, this is the triangle here now, AIB. In triangle AIB, what is there? Sine R. So what will be sine R? Sine R, this case, this is the perpendicular again, and this is the angle R. So it is again P over H. So P here is again AB and H here is IB. Is it? So we are knowing the definition of refractive index. What is refractive index? Refractive index is the ratio of refractive index mu is equal to ratio of sine of the angle incidence and sine of the angle of refraction. and here in this case if we put the values of sin I is AB over OB, and sin R is AB over IB, is it? So what will be this? AB over OB into, this will change, this will become IB over AB. So AB and AB both will cancel, so refractive index will come what? IB over OB, is it? IB, this one, IB over OB, is it? So since this point B is very close to point A, is it? B point is actually very close to A, because this refraction can take place at any point on this surface, is it? Here we have considered this point B is at a distance because we have to draw this diagram, is it? Otherwise we will not be able to understand this angle, where is the angle I and where is the angle R. So that's why we have taken it at a distance, is it? Otherwise this point B is very closer to point A, is it? So if this point B is closer to point A, then what will be there? This distance OB, will be equal to OA, is it? Because this point B is very close to A, is it? So if point B is here, then what will be the distance OA? That will be the distance OB, because it is very near to A, is it? So therefore you can see from here, distance OB is approximately equal to OA, is it? And distance IB that will again be approximately equal to IA, is it? So this will be equal to refractive index is equal to, if we put IB can be written as IA, and OB can be written as OA, is it? So IA over OA. So this is the refractive index of air with respect to water, is it? This is the refractive index of air with respect to water, that will be IA over, just a minute, it will be like this. The refractive index of air with respect to water, that will be IA over OA. So if we had to find the refractive index of water with respect to air, what will be that? Then this will reverse, is it? It will become OA over IA, is it? So OA, if you see from this diagram, what is OA here? OA is actually this total depth, is it? OA is total depth. So this total depth is actually called the real depth, is it? This total depth is the real depth, and IA, this distance, is it? IA here, this distance, is it? So this distance is actually known as the apparent depth, is it? This distance is apparent depth, right? Clear? This distance is apparent depth. So here we can say now refractive index is equal to OA. OA is what? OA is now real depth, is it? OA is the real depth, is it? And IA is the apparent depth, right? So it means refractive index of water with respect to air is equal to real depth over apparent depth, is it? So simply this relation can be asked sometime, is it? That prove that refractive index is equal to real depth over apparent depth. So you can solve in this way. It is quite simple. Refractive index is equal to real depth over apparent depth. That refractive index is equal to real depth over apparent depth. Is it? So this is the relation. So sometimes this formula can be asked, that what is the relation between refractive index and real depth? Is it? How the real depth and apparent depth is related to the refractive index? That can be asked. It can be asked.